Hello, welcome to On Wildlife. I'm your host, Alex Ray. On this podcast, we bring the wild to you. We take you on a journey into the life of a different animal every week, and I guarantee you're going to come out of here knowing more about your favorite animal than you did before. On this episode, we're talking about an animal that's relatively small, but has one of the most powerful punches in the animal kingdom. And their punch isn't the only thing that makes them unique, because they have senses that put ours to shame. So join me as we dive into the ocean to talk about Mantis Shrimp. Mantis shrimp are crustaceans that belong to the order Stomatopoda and the genus Squilla. There is a large amount of diversity among these animals. In fact, there are more than 350 known species of mantis shrimp. Because of their large diversity, they also have a wide range in many oceans across the world. One of the more well-known types of mantis shrimp is the Squilla mantis, which is native to the Mediterranean Sea and parts of the Atlantic Ocean. Along the Atlantic coast of North America, the most common species is the Squilla ampusa. These organisms make U-shaped burrows and hunt at night for smaller fish species. And we're going to talk about their hunting techniques later on in the episode. The Oratosquilla oratoria is common to the coasts of Japan. However, unlike its counterparts in North America, it's considered a delicacy in Japanese culture, and most of the time it's eaten as sushi. Maybe the coolest looking species is the peacock mantis shrimp, which has an elaborate color scheme filled with shades of all different colors. That species, along with most mantis shrimp species, are native to the tropical Pacific and Indian Ocean waters. They're found in and around coral reefs, which are also really colorful. And even though many enjoy the reefs, there are a few species that prefer deeper waters, which can get as deep as 4,300 feet down. That's more than 3/4 of a mile underwater. Mantis shrimp can be anywhere from a half an inch long to a whole foot in length. Now, you may be wondering if the mantis shrimp's name is related to the praying mantis, and you would be correct in thinking that. The reason why their names are so closely related is because the second pair of limbs are enlarged, and they look very similar between both organisms. The way their forelimbs are positioned makes it look like they're praying. And the reason that the mantis shrimp has these limbs has to do with what they eat. Mantis shrimp usually like to eat small fish and other crustaceans, and their enlarged limbs are perfect for breaking open shells that their prey uses for protection. The peacock mantis shrimp has one of the faster punches compared to other mantis shrimp, and they actually have the fastest punch in the animal kingdom. In fact, in 1998, a mantis shrimp named Tyson punched through the glass that was holding him inside of his aquarium. The glass was an inch thick. The reason they specifically have a fast punch is because of their reliance on hard-shelled crustaceans. In order to break their prey's protective shell open, they need a fast, power-packed jab to shatter it apart. With this, it can easily dismember crabs, shrimp, and other crustaceans that have larger shells. And it doesn't just crack the shell of the organism, it blasts it open with the force of a .22 caliber bullet. Having the muscle strength for that kind of power is not seen in the aquatic animal kingdom. The way the mantis shrimp achieves this power is through its spring-loaded forelimbs. When it releases the spring, the limbs move at the speed of 23 meters per second. This has earned the mantis shrimp the reputation of thumb splitter. Fishermen gave it that name for its reputation of making some bloody thumbs when they're removed from nets and traps. But there are multiple different methods that mantis shrimp use to catch their prey, and the method they use depends on the shape of their claws. They can be split into two categories, smashers and spearers. Smashers, as the name suggests, smash open the protective shells of the prey. Their limb is shaped like a club with sharp mineral deposits to add an extra bit of strength. Think of a smasher's claws like a golf club, meant for pure power. In general, their prey aren't in short supply, and this is because many other organisms aren't able to open their shells. Spearers, on the other hand, stab through their prey. Just like a knife, the tip of their appendage is sharp, so it can cause more damage with punctures to the prey. They don't really break through shells like smashers do, because their claws aren't built for that. They're really meant for quickly catching fish. Because of the powerful punch that these animals have, when two mantis shrimp meet, they usually don't try to attack each other. They're not immune to their own punches, so a fight could easily result in severe damage or death. So what happens when individuals do meet up with one another? We'll talk about that right after the break. The person that I want to recognize on this week's episode of Notable Figures in Science is Ada Lovelace, an English mathematician. She was alive in the mid-1800s, and you know those people who were just ahead of their time? Well, she was one of them. As a child, she learned math, music, and French, and was very interested in mechanical ingenuity. She was known as the first computer programmer in the world, and you might think this is strange considering that computers hadn't really been invented yet, but she was the first person to write an algorithm for a computing machine. She even mentioned how codes could help devices handle strings of letters, numbers, and symbols. Unfortunately, her work wasn't discovered until the 1950s, but she was given many awards after her death, and a new computer language was even named after her in the 80s. If you want to learn more about Ada Lovelace or this series, check out onwildlife.org. Okay, welcome back. Mantis shrimp are, for the most part, nocturnal. And because of this and the fact that they can live in the depths of the ocean, there's still a lot we don't know about their behavior compared to many other organisms. But we do know that their mating strategies are very dependent on their specific species. Certain species will have different mating partners throughout their whole life, while others are monogamous. Some species have a certain time period of sexual maturity, while others can mate for their entire lives. For species where there are more predators present in their ecosystem, the male will guard the female a few days before she plans on laying her eggs. Females have paired ovaries, just like humans, and they have the ability to create a cementitious substance which holds their eggs together. Depending on the species, she does a few different things with the eggs once they're fertilized. The female will either retain the eggs when the fertilization occurs, place them in her burrow, or keep them on her forelimbs. This is all dependent on the species and the predators in the ecosystem. To make sure that the eggs are safe and clean, the female mantis shrimp will use maxillipeds, which are structures on the mouth, to clean the eggs and ensure that water is always present around the eggs. Usually, the maxillipeds are used for feeding by bringing broken down pieces of food to the mouth. The female is also able to store the sperm given to her by the male until she's ready to start laying eggs. And once the eggs hatch, the baby mantis shrimp leave their U-shaped burrows. And when they're born, they're extremely small, and they don't have all the appendages that an adult would have. For this reason, as they grow during the larval stage, they generate their appendages. This stage can take anywhere from 1 to 3 months. And once they're at their largest size, they live on average for 3 to 6 years. Some species have a greater tolerance and life length, living up to 20 years. Unfortunately, like many other aspects of this animal, there's relatively little information regarding the mantis shrimp's social structure. Most of the time when they're meeting, they're trying to mate. And despite their small size, mantis shrimps are actually really intelligent. They maintain their memory of other individuals using sight and smell. Just like a dog can recognize another dog by its unique smell, mantis shrimps can do the same with other mantis shrimps. Aside from smell, mantis shrimp can communicate through light, and the way they see the world is completely different from how we see ours. They use their eyes to focus on their surroundings with 3 different parts of their eye. It gives the shrimp a trinocular depth perception with one singular eye. Humans, on the other hand, only use two parts of their eye for depth perception. Humans also have 3 cones in our eyes for detecting red, yellow, and blue light, but mantis shrimp have 16 different cones in their eyes. When we see, we're only seeing a jumbled mess of all these light waves bouncing off of each other in different directions. But because of the cones in their eyes, mantis shrimp can see individual waves of light. And they're the only animal that can see a unique type of light wave that's able to twist and turn in different directions called circular polarization. And what's even more interesting is that the shell of the mantis shrimp reflects the circular polarization, and each mantis shrimp has its own signature polarization wave. This is how the shrimps can identify each other, as well as communicate with each other. The exact waves and signals are unknown in terms of what they mean, and this whole phenomenon was discovered relatively recently in 2008 by Justin Marshall from the University of Queensland. However, there are some clues. Before fighting with each other, the shrimps will curl up and expose their entire shell, which reflects the waves of light. Scientists hypothesize that they do this to reflect a warning signal to the other mantis shrimp. They also display these behaviors when they're courting mates. Along with their fierce punch, they're also very territorial that prefer to live alone. They're also very protective of their burrows, both from predators and other mantis shrimp. The only types of species that defend the burrow in a pair are those that are monogamous. They're also known for their complex social behaviors with other mantis shrimp, including their ritualized fighting, bonding with their female, and interactions with others close to their burrows. And the fights between individuals are really interesting because they don't require a shrimp to hurt another shrimp. Mantis shrimp know that their punches can kill each other, so they don't really punch each other. The shrimps will gather and test out their punches, but not on each other. Whichever mantis shrimp has the strongest punch usually is the winner. While researchers are relatively confused by this behavior, they believe it can be used for both communication and to resolve conflicts without blood. But when there's a more intense situation between individuals, the animals will throw punches at each other. However, the winner of the fights is usually the shrimp that throws the most punches rather than the most powerful. To defend against the punches, the shrimp can actually curl up its tail, which lessens the impact. Okay, we're going to take a quick break, and when we get back, we're going to talk about why mantis shrimp are so important to the ecosystems that they live in. Think you can answer today's trivia question? Here it is. What is the tallest tree species in the world? A redwood, B, a giant sequoia, C, a maple tree, or D, a bald cypress? The answer is A. A coastal redwood can get to be over 350 feet tall. Okay, we're back. So why are mantis shrimp important to the ecosystems that they live in? Well, for starters, they're a regulator species, which means that they work to keep their prey's population in check. Since they're some of the few organisms capable of consuming other marine animals with shells, they're crucial to maintaining these populations. The most common predator for these shrimp are the yellowtail tuna, so mantis shrimp help their populations. However, there's been a large decline of yellowtail tuna because of overfishing, so the mantis shrimp have actually been increasing in population. They're also very sensitive to the environment around them. For this reason, they're great indicators for the health of coral reefs. When there are lower populations of mantis shrimp, there's a higher likelihood that the water quality or food resources are low within that ecosystem. More than just having a large ecological importance, mantis shrimp have also helped humans with both visual and audio storage. Their unique communication techniques with light have encouraged scientists to explore more into circular polarization. Maybe in the future, we can use their abilities in order to sense things that we've never been able to see before. Luckily for these shrimp, People don't fish for them or put them in aquariums because of their powerful punch. Because many types of mantis shrimp aren't endangered, there are fewer organizations focused on their protection. However, general organizations like Oceana, Great Barrier Reef Foundation, and Coral Reef Alliance are great places that help the habitats that mantis shrimp live in. Thank you so much for coming on this adventure with me as we explored the world of mantis shrimp. You can find the sources that we used for this podcast and links to organizations that we reference at onwildlife.org. You can also email us with any questions at onwildlife.podcast@gmail.com. And you can follow us on Instagram at on_wildlife or on TikTok at onwildlife. Don't forget to tune in next Wednesday for another awesome episode. And that's On Wildlife.
You've been listening to On Wildlife with Alex Ray. On Wildlife provides general educational information on various topics as a public service, which should not be construed as professional, financial, real estate, tax, or legal advice. These are our personal opinions only. Please refer to our full disclaimer policy on our website for full details.